Yeah, good evening, everyone. And today we are discussing the chapter trigonometry. So actually, in our trigonometry, we have started our trigonometry chapter from the definition of triangles. Okay, from the definition of triangles, we have because from the basic concept onwards, we have started the trigonometry, and that is from the triangle onwards. So you know what is triangle? A triangle is a closed figure. Just look at this. A triangle is a closed figure bounded by the three lines, three straight lines. Not straight lines, line segments we can say. Instead of straight lines, we can say line segments. Okay, line segments. Oh, it is denoted by symbols triangle. The triangle symbol is denoted by this, and the triangle has three sides. And normally, see sides in regular class we say sides, but in normally we say edges here. Here edge 0, edge 1 and edge 2. Three edges we have. Same way a triangle has three vertices, that is vertex vertex 0, vertex 1 and vertex 2. Okay, or else we can denote it by A and B and C. Here it is A and here this is B and this is C vertex. So it's three angles. Okay, so here vertices are denoted by A, B, C, and we say here angle is see simply we say vertex has A, B, C, but coming to this angles we say it is angle A and angle B and angle C, right? So this is nothing but a triangle. See, it is a closed figure bounded with three line segments. Okay, and it has three sides or three edges and three vertices. Okay, and that vertices I am denoting with the capital letters, that is ABC, or we say vertex O, vertex 1 and vertex 2, or vertex 0, vertex 1 and vertex 2, right? Next, coming to see classification of triangles. So we have a types of triangles we have. See, according as per sides we have a equilateral triangle. Okay, as per sides we have equilateral triangle. What is an equilateral triangle? A triangle which has all the three sides are equal. A triangle at all the three sides are equal, we call it as equilateral triangle. And isosceles triangle, any two sides, not only these two sides, if any two sides of a triangle are equal, we say it is an isosceles triangle. And the scalene triangle, you know scalene triangle, if all the three sides are different in length, if all the three sides are different in length, we say it is a scalene triangle. Different in length means, suppose one is 3 centimeters and one is 5 centimeters and one is 7 centimeters. All these sides are different in length, we say scalene triangle. The very important thing is, see here, all the three sides are equal. When all the three sides are equal, their angles also equal. Suppose this is angle, this is angle, this is angle. Suppose this is A, angle A, and this is angle B, and this is angle C. So we say here angle A equal to angle B equal to and angle C, because all the three sides are equal means at the same time all the three angles also equal, right? But coming to isosceles triangle, any two sides are equal, any two sides are equal. Suppose if this vertex I am denoting it as A and this vertex I am denoting it as B, and this vertex if I am denoting it as C. Here AB equal to AC, observe carefully, AB equal to AC. Okay, AB equal to AC. Here AB equals to AC means here A is the common here. So implies and implied. Implies and implied, we say angle B equal to angle C. Angle B equal to angle C. Here AB equal to AC means implies and implied. Why I am saying implies and implied? Because see, if two sides are equal, their opposite angles are equal. If two angles are equal, their opposite sides are equal. Understand? If two sides are equal, their opposite angles are equal. If two angles are equal, their opposite sides are equal. So this is what isosceles triangle. See, in any isosceles triangle, if two sides are equal, their opposite angles also equal. If angles are equal, we say that opposite sides are equal. But coming to the scalene triangle have all the three sides are different in length. So here you cannot say this any of the angles are not equal and any of the sides are not equal. So that is nothing but a scalene triangle. But coming to this angles, right? So in terms of angles property, okay, see, acute angle means if all the angles are less than 90 degrees. Observe carefully. Here each angle is less than 90 degrees. Less than 90 degrees means it may be 70 degrees. This may be 40 degrees, and this may be, or this may be 50 degrees you take, and this may be 50, and this may be 60 degrees. See, all the angles are different. See, this is 70 degrees, this is 50 degrees, and this is 60 degrees. All the angles are less than 90 degrees. As all the angles are less than 90 degrees, we say it is an acute angle triangle. Understand? So here, see, when can we say acute angle? We have to check the angles. If all the angles are less than 90 degrees, but whose sum must become 180 degrees? See, 70 plus 60 plus 50 is 110, and 110 plus 70 is 180 degrees. Okay, so acute angle triangle whose sum of three angles is 180 degrees and each angle is less than 90 degrees. Understand? And coming to a right angle triangle, any one of the angle is 90 degrees. See, any one of the angle, I can say if one angle is 90 degrees in terms of triangle, if one angle is 90 degrees, we say it is a right angle triangle. See, if this is the symbol of 90 degrees. If this is a 90 degrees and these two angles whose sum becomes 90, maybe this is 60 degrees, this is 30 degrees, this is 30 degrees. Okay, so 90 plus 60 plus 30 will become 180 degrees. But if one angle has become 90 degrees, it is right angle triangle. And coming to obtuse angle triangle, if one of the angle is greater than 90 degrees, suppose this is 110 degrees. If this is 110 degrees, okay, if one of the angle is greater than angle, see, all the three angles cannot be possible because whose sum of angles must become 180 degrees. It must see any type of triangle or any type of acute angle triangle or normal triangle, they must satisfy angle sum property. What is an angle sum property? Sum of three angles equal to 180 degrees. That is nothing but angle sum property. See here one of the angle is 90 means whose remaining sum angles will become 90. 60 plus 30 90 and this will become 90 will become 180. If this one of the angle is 110 degrees means remaining angle will be 70 degrees. No, this will be 30 degrees. This will be 30 degrees and this can be 40 degrees. Following me? So total will become what? 180 degrees. So acute angle means all the angles will be less than 90 degrees. Right angle means if one angle is 90 degrees, it is a right angle triangle. And coming to obtuse angle triangle, okay, coming to obtuse angle triangle. Coming to obtuse angle triangle, if one angle is greater than 90 and remaining angles will be acute. So such type of triangle is nothing but obtuse triangle. Next, we come to this congruency of plane geometrical figures. What is congruency? Well, congruency is nothing but two figures or shapes are said to be congruent. So when can we say the two figures or shapes are congruent? If they have same shape and same size. Or same shape and same size is nothing but what? Exactly overlap is nothing but what? If you take our hands, if we put one upon other, so exactly they overlap. Exactly they overlap. So we can say the two hands are congruent. I mean, two hands are said to be congruent figures. Understand? So exactly overlap is nothing but one upon other. If you give exactly, they must coincide their edges, vertices, and everything. Okay, so here examples are given. Two line segments are congruent. Yes, two line segments are congruent. I mean to say, suppose two line segments, suppose one line segment is 5 centimeters and another line segment is also 5 centimeters if I take. Okay, then both are line segments and both are same measure. Both are line segments and both of them are same measure. Therefore, we can say these two line segments are congruent, right? See, if their lengths are equal, I mean 5 centimeters, 5 centimeters. Both the line segments are 5. This is, suppose this one line segment is 5 centimeters and this line segment is also 5 centimeters. As both the line segments are 5 centimeters, we can say they are congruent figures. Same way, if they measures, see, when can we say if they have same measurement, same structure and same measurement. Measure is nothing but length. Just observe these figures. These are the two triangles. If these two triangles, if we keep one upon other, they exactly overlap. As they exactly overlap, they are congruent figures. Here you say this is, see, six-sided means hexagon. Hexagon, if we keep these two hexagon one upon other, they are nothing but they exactly overlap one upon other. So they are also nothing but a congruent figures. Here if you say this is five-sided figure, which is nothing but pentagon, again if we keep these two figures one upon another, they exactly overlap. So next one is also exactly overlap. So these figures are said to be congruent figures. So what is congruent figures? Same size, same shape. Still, we want more clarity means if we keep the two figures one upon another, they must overlap each other, right? Next. Next here you see congruency of triangles are different types. See, suppose here ABC is one triangle and DEF is another triangle. But here these two triangles are congruent, we can say. What is the congruency condition we have to find? What, see, triangle ABC, triangle ABC, triangle ABC, observing triangle ABC, okay, congruence to this is the congruent symbol, wave shape and equal to down, congruence to ABC. Observe this, how the figure is moving from 7 centimeters to 50 degrees to 5 centimeters. It is closing. It is starting from 7 centimeters and angle 50 degrees and it is closing at C. Again here also, see, you cannot take here DEF triangle. You cannot take here DEF triangle. Are you following? You cannot take DEF triangle. See, DEF if I take, but see, observe carefully, very important thing, this is A, B and C. Means it is starting from 7 centimeters and at middle 50 degrees and it is closing at 5 centimeters, passing through 5 centimeters, it is closing. So here also observe that carefully, from F onwards it is starting from 7 centimeters and at middle it is 50 degrees and it is passing 5 centimeters to D. Means triangle ABC is congruent to triangle FED here. Triangle FED. Are you getting me? Triangle ABC is congruent to triangle FED. Triangle ABC is congruent to triangle FED. Are you following? If you write triangle ABC is congruent to triangle DF, it is wrong. Are you getting me? Triangle ABC is congruent to triangle DF, it is wrong. Triangle ABC congruence to triangle DEF. If you write DEF, if you write DEF, this is wrong. Understand? Because see, the angles property, it must, see, two triangles must become congruent, it must satisfy the sides and angles also. Like see, it is starting, see, this ABC is starting from A to B is 7 centimeters, B to C is 5 centimeters. Here F to E is 7 centimeters, E to D is 5 centimeters. Means triangle ABC is congruent to triangle FED. Are you getting me? This is very important. See, everyone your teachers, you know very well, but you have to explain the difference. So how to write the vertices? From vertex A I am starting, it is B, it is middle, and C it is ending. Means 7 centimeters to 5 centimeters it is ending. So here also vertex F onwards, it is starting from 7 centimeters and it is ending at 5, passing through 5 centimeters and ending with D, right? It is very important to explain to the children. Next, congruency of two triangles. See, two triangles are said to be congruent when, see, there are many things are their properties. Two triangles are said to be congruent. Number one, corresponding angles are equal, and number two, corresponding sides are proportional and equal. Very, very important. Sir, suppose here ABC is one triangle and DEF is another triangle. Corresponding angles means angle A equal to angle D, angle B equal to angle E, angle C equal to angle F. Understand? Corresponding angles are equal. Just observe this. Top angle, left angle, right side angle. Corresponding angles are equal. And same way, corresponding sides are proportional. BC by EF equal to BC by EF equals to, see, first side it is. Second side is what? AC by DF. AC by DF equal to. Next, third one is AB by DE. Observing here, see, if you suppose the question raises like this, if write the corresponding parts of a triangle. See, these are nothing but corresponding sides. What about the corresponding angles means angle A equal to angle D. Angle A equal to angle D is a corresponding angles. Angle B equal to angle E is an corresponding angles. Angle C equal to angle F is an corresponding angle. Are you getting me? See, these are the corresponding angles, these are corresponding angles, and these are corresponding sides. So combinedly we say that corresponding parts of congruent triangles. What are, see, normally every time we say that CPCT, will teach to the children CPCT. What is CPCT? CPCT is nothing but corresponding parts of congruent triangles. What are corresponding parts? Corresponding parts are nothing but corresponding angles and corresponding sides. So combination of corresponding angles and corresponding sides makes an CPCT. What is CPCT? Corresponding parts of congruent triangles. Corresponding angles and corresponding sides may includes, says that CPCT. Following. Next, you see here two triangles again, just whatever I discussed just before. Corresponding angles A and D. Angle A equal to angle D, angle B equal to angle E, and angle C equal to angle F. Here AB equal to DE, BC equal to EF, and AC equal to DF. So ABC is equal to DEF means no. ABC and DEF are not DEF. See, DEF is not. It is some mistake was there. It is not DEF. It is just before we discussed FED. It is just ABC is congruent to DEF. Yes, ABC. It is start from A, B, and C. It is third, 3, 1, C, 3, 1, F. Yes. So it is ABC is congruent to right. ABC is congruent to triangle DEF. Congruent or no? Right. So what it can read as? It is read nothing but triangle ABC is congruent to triangle DEF. Right. Next, CPCT. Just before we discussed what is CPCT, I said CPCT. It is nothing but corresponding parts of congruent triangles. See, two congruent figures are equal in area. Suppose if two congruent figures means two triangles only if we take, but two figures having the same area need not be congruent. See, if two figures are congruent, they are equal in area. Yes, because two figures are congruent means it has same length and same length. I mean same vertices, same angles, and same sides will be what? Proportional. But if two figures have equal area, they are congruent. They are see, two figures are congruent, they have equal in area. But if two figures are have equal area, need not be a congruent. Example, if we take one example, suppose this is a one triangle, this is another triangle, okay, and whose height is 5 centimeters and whose base is 8 centimeters, and here whose height is 6 centimeters, or else, yeah, 6 centimeters, not 6, 5 centimeters, and whose height is 8 centimeters, suppose. Okay, so what is the area means? See, area will become what? Area means area equal to half into base into height. Yes, half into base into height, half into base into height, which is nothing but half into, here for first triangle, for first triangle base will become 8 and height will become 5. So the answer will become 20, no? Answer will become 20 square centimeter square. Okay, here also it will become 20 centimeter square only. But observe here, these two triangles are not congruent. They are not congruent. They are equal in area, but they are not congruent. They are equal in area. Here areas are equal for both of them. This is base is 8, height is 5. Here base is 5 and height is 8. Whose areas are equal? If you find the area for this triangle also, you will get 20 centimeter square only. Okay, but areas are equal, but they are not congruent. So from this what we can say is, if two triangles are congruent, they are equal in area. But if the two triangles have equal area, there it doesn't mean they doesn't need to be a congruent. Understand? So two triangles have equal area, they doesn't need to become a congruent compulsory, right? This is what the important topic. And what are the types of congruency? We know what are the types of congruency. Here SCS, SSS means side side side, and this is AS, side angle, angle side. Okay, here angle and here is the angle we have to take. Angle side, here is the angle we have to take, right? Angle side, and here it is two sides, one angle, side angle side. Here it is RHS rule. This is right, this is right angle, this is hypotenuse, this is side, RHS rule. And this is angle side, angle side, right? So these are the types of congruence triangles. And next, observe carefully here, just whatever we have discussed just before, just it is given in one slide. It is just scalene triangle, equilateral triangle, and right angle isosceles triangle. You know scalene means all sides are different. Right angle, one of the angle is 90 degrees right angle, and equilateral all sides are equal. Okay, scalene is all sides are different. Isosceles is any two sides are equal. Just slide it is. Next, observe here what triangles and its properties means. These all informations are very important, basic information it is, right? And observe this, you know very well is that, observe this one, exterior angle is equal to sum of two interior opposite angles. Very important. Here this is an exterior angle, here this is an exterior angle, this angle 4 is an exterior angle, angle 1 and angle 2 and opposite interior angle. So angle 4 equal to angle 1 plus angle 2, we can say. Angle 4 is an exterior angle, angle 1 and angle 2 are interior opposite angles. So angle 4 equal to angle 1 plus angle 2, right? And coming to here, sum of three angles 180 degrees, this is called angle sum property, you know very well. Okay, and very important thing here is, see, whatever the sides are given, whatever the sides measurement are given, that measurements will become, I mean, with that measurements can triangle can be constructed or not, how can be defined, or else the given measurements can satisfy the triangle property or not, how can we know? By adding any two sides, their sum must become greater than the third side. This is nothing but a triangle property. Understand? What is triangle property? Here, sum of any two sides must be greater than third side. Any two sides. All the sides you have to check. AB plus BC, BC plus AC, AB plus AC. Any two sides if we add, they must be greater than third side. Then we can say the given measurements can construct the triangle, or the given measurements can form a triangle, we can say. Understand? Next, coming to here, you see here it is an equilateral triangle. No, all sides are equal means each angle will be 60 degrees. And this is an isosceles triangle. Any two sides are equal. This is an scalene triangle. All sides are different in measure. Next, lines. And this is a median. See, from opposite vertex to the opposite side, if you draw a line segment, vertex to the opposite side, that line segment is nothing but a median, and this median will divide this opposite side in two equal parts, like B to D, whatever the distance will be there, and D to C also will be same distance will be there. If we draw one more median also same, like this, vertex to the opposite side we can draw. Here whatever the distance will be there, this is also same distance will be there, right? And from here onwards also we can draw one more median, means vertex to the opposite side. Here whatever the distance will be there, the same distance will be here. Understand? So we can draw three medians. See, because three vertices, three sides are there for the triangle, no? So we can draw three medians like this. And here you see, just any triangle has three medians. Any triangle has three medians here. And here you see perpendicular segments. These are perpendicular means 90 degrees it will form. Altitude we can say. When an angle forms 90 degrees, altitude you can say. What is the difference between the median and altitude? Very important thing. See, median means altitude means, see, median will divide the opposite side into equal parts. But vertex will not divide the opposite side into equal parts. It just makes 90 degrees with the vertex. It just make 90 degrees to the opposite side. See, it is just making 90 degrees to the opposite side. Here in medians it will make 90 degrees to the opposite side. At the same time it will divide the opposite side in two equal parts. But coming to altitude, it just make 90 degrees to the opposite side. It cannot divide the opposite side in two equal parts. That is the difference between the median and perpendicular, right? And this is also, so altitude only. And altitude. Position of right angle triangle, you know this. Obtuse angle, you know this. And here right angle triangle we discuss next, right? So here, and triangle inequality, very important. See, triangle inequality means, just before I said, if three sides are given measurements, are given, sum of any two sides must be greater than third side. Observe here, A plus B is greater than angle C, A plus C is greater than B, and B plus C is also greater than A. So we can say sum of any two sides, okay, must be greater than third side. Then we can say it is triangle inequality. Okay, next, triangle inequality theorem, nothing, just sum of any two sides must be greater than, again we are showing here. Okay, next, coming to trigonometry, actual chapter. So trigonometry, see, it is a Greek word, it is Trigonometron. The original name of that one is Trigonometron. It is later it was named it as trigonometry. The measurement of three angles. See, tri means three, gonia means angle, metron means measurement. The measurement of three angles we say. But I say here, see, what actually we find with the trigonometry means, trigonometry totally deals with the right angle triangle. Observe carefully. Trigonometry deals with the right angle triangle. And what we find actually in a trigonometry means, when sides are given, we find angles. If angles are given, we find sides. Okay, so here whatever, see right angle triangle have three angles and three sides. Even right angle triangle also, if one angle is given, remaining angles we can find using this trigonometry. Understand? If two angles are given, we can find sides of the right angle triangle. If sides are given, we can find angle of the right angle triangle. This is the quality of trigonometry. Understand? And trigonometry we have different trigonometric signs we have. like sine and cos and tan. Sine, cos and tan, okay, are the three trigonometric signs. Actually everybody will say that there are six trigonometric signs. No, we have only sines: sine, cosine, tangent. Actually the full names are sine, and this is cosine, and this is tangent. Only three trigonometric signs we have. Their reciprocals, sine reciprocal is cosec, sine reciprocal is cosec, and cos reciprocal is sec. Cos reciprocal is what? Sec. And tan reciprocal is cot. Tan reciprocal is cot. Understand? So sine reciprocal is cosec, cos reciprocal is sec, and tan reciprocal is cot. So totally combines makes 6 trigonometric signs. Actually we have only 3 trigonometric signs, that is sine, that is sine, sine, cosine, cos, tangent, tan. See, their reciprocals means sine reciprocal is cosecant, cosec, cos reciprocal is secant, sec, tan reciprocal is cotangent, cot. Understand? Just if you read this all, see Bhaskaracharya, this name as sine. Okay, Aryabhatta, it was introduced the name Jaya, it led to name sine. See, this sine was introduced by Aryabhatta. And Bhaskaracharya also introduced this Jaya, which is presently used as sine, cosine and tangent. So now totally there are Aryabhatta and Bhaskaracharya and Goladhaya, these all, and Kautijaya. Word Jaya, Kautijaya is used as what? Sine, cosine and Sparsha Jaya is tangent. Jaya is sine, Kautijaya is cosine, okay, cos, and Sparsha Jaya is tangent. So like this they have kept the name. Later the name has become what? Modern way, like sine, cos and tan. Next, observe here angle. You know angle. See, the union of two rays. OA is one ray and OB is another ray. If two rays joined with the initial point, OA and OB. O is a common initial point. O is what? Common initial point. So if two rays are joined at common initial point, then they form an angle. An angle. Here O is called initial point. O is called what? Initial point or initial position. And this OA and OB are called arms or terminal side. See, OA is an initial side and OB is an terminal side. And the angle formed in between them, it is nothing but angle. Following? Right? Next. Now sense of an angle. See, very important. See, here observe this AOB first. Here observe this. If you observe this AOB, here the rotation is given like this. Means rotation is what? Clockwise rotation, because it is moving like this. Understand? It is moving like this. It is moving clockwise rotation. So when the rotation is clockwise, okay, when the rotation is clockwise, we will get negative an angle. If the rotation is clockwise, we get negative angle. Here the rotation is given this way, anti-clockwise. Are you following? So like this, there it is moving. Like arrows are like this. Arrows are like this. Okay, if the rotation is what? Anti-clockwise. If the rotation is anti-clockwise, it is the angle formed is positive. If the rotation is clockwise, the angle formed is negative. If the rotation is anti-clockwise, the angle formed is positive. Understand? So next, now see this quadrant. See, normally here this is nothing but here x and x dash. Here x and x dash. X and x dash. Here x dash, this is nothing but horizontal line, and this is nothing but vertical line. Understand? This horizontal line is called x-axis. This horizontal line is called what? X-axis. And this vertical line is called y-axis. This vertical line is called y-axis. Okay, horizontal line is nothing but x-axis and vertical line is nothing but y-axis. This horizontal line and vertical line are meeting at one point. This point is called origin. 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 And the vertex will be like 0 comma 0. Vertex will be like what? 0 comma 0. 0 comma 0. Understand? So this horizontal line and this vertical line will intersect at one point. That point is called origin. And what actually this is nothing but a plane. This is nothing but a plane. And this horizontal line and vertical line dividing this plane into four parts. This is one part, this is second part, this is third part, and this is fourth part. So each part is called quadrant. First quadrant, second quadrant, third quadrant, and fourth quadrant. Each part is called quadrant. This horizontal line and this vertical line dividing this plane into four equal parts. Each part is called quadrant. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. Normally we know that OX is nothing but positive because right side will be positive. OY is also positive. That is the reason here in first quadrant we will have both the x and y values will be positive. X and y values will be positive. And coming to here, OX is negative because left side is there, no x-axis, and OY is positive. So minus comma plus. Minus comma plus. And coming to here OX is negative and OY is also negative. So both are minus sign. Here coming to here, OX is right side, no, it is positive. OY is downside, no, it is negative. So here x is positive, y is negative. So this is positive comma negative. And remember every time first we have to write positive x quadrant value and next y quadrant. First is x and next is y. That is the reason x values we are writing first, next y value. Means here x values are positive and y values are positive. That's why positive and positive. Here x values are negative, y values are positive. So negative and positive we write together. Right? Next here. Next here, see here we have just now we discussed the rotation starts from here because this is a center point. If the rotation is moving in anti-clockwise direction, it is a positive angle. That is the reason. Suppose if this is at 0 degrees, then angle will be taken here. This is 90 degrees. Here it is 90 degrees, and here it is 180 degrees. And here it is 270 degrees. And again here when it comes to end, because where it is starting again it is closing there, it is 360 degrees. Understand? So one complete rotation is completed. But how the rotation is in a anti-clockwise direction. Understand? If the rotation is in anti-clockwise direction like this, then the angle is forming 90, 180, 270 and 360. This is nothing but 90, 180, 270 and 360. This is positive angle because it is moving in a positive angle, means anti-clockwise direction. If it is moving in a clockwise direction, observe here, this is moving in a clockwise direction here. So here what is the angle forming here? Negative angle forming. See here, what is the angle forming here? Negative angle forming, because like this if it is moving and clockwise direction it will become, when the angle starts moving in a clockwise direction it have a negative angle, right? Next we have types of angles, system of angle measurements. Sexagesimal system, or we can say it is an English system also. Sexagesimal system, or we can say English system also. Nothing, just see, one right angle is equal to 90 degrees. 1 degree will be divided into 60 equal parts. Each part is called minutes. Again each minute again divided into 60 equal parts. Each part is called seconds. That's all. Understand? One right angle equal to 90 degrees. 1 degree will be divided into 60 equal parts. Each part is called in minutes. Again 1 minute is divided into 60 equal parts. Each part is called seconds. That's all. See here 90 degrees. See, some of those angles are 90, 45, 60. These are all angles shown in the, we can show it in the figure. Right? Next. Here you just see, just I am showing 90 degrees, this is angle, this is 45 degrees, and this is 60, 30, you know very well, this is 360 degrees means complete rotation, and this is 180 degrees, this is 270 degrees, this is 270 and this will become 90 degrees, this is 42, this is 30, and this is minus 420, because it started here, again one complete rotation completed, again one more some space it is moved, so it is totally 420 degrees minus. Circular system, very important. Circular system is nothing but it is defined with the radians. See what is circular system is angle subtended at the center of circle by an arc of length equal to the radius of circle. See whatever the angle subtended here is equal to the center of circle by arc of length equal to this arc length. This arc length is equal to, this is the arc length. Again this is the arc length and this is the arc length here. This is the arc length and this is the arc length. Are you following? Every part of a circle is called an arc. Every part of a circle is called an arc. Every part of a circle is called an arc. So this is nothing but arc length. So arc length is equal to what? Length. Arc of length is equal to the radius of the circle. If the arc of length is equal to radius of circle, we say it is an radians. Okay. It is an radian. See, 1 radian means how can you invent 1 power c. It is nothing but 1 radians. The very important thing here is pi radians is equal to 180 degrees. Pi radians is equal to how many degrees? 180 degrees. It is cursor is not moving little. Try to understand. Pi radians is equal to 180 degrees. I want 1 radian means 1 radian is equal to, this pi comes to denominator, 180 degrees by pi. Are you following? 180 degrees by pi. See, pi c is equal to 180 degrees means pi radians is equal to 180 degrees. Pi radians is equal to 180 degrees. 1 radian I want means this pi comes to denominator. So 1 radian is equal to 180 by pi. Right? Very, very important. Next, observe here. Observe here, these are radians. The figure shows the angle. See, 1 radian, minus 1 radian, 1.5 radian, minus 1.5 radian. Because clockwise is positive, anti-clockwise is negative. Here is also clockwise positive. Here it is Here it is anti-clockwise is positive. Anti-clockwise means positive. You know that. Okay, and it is here the angle is moving in a anti-clockwise to positive. Here angle is moving in a clockwise direction. It is negative. Here is also angle is moving anti-clockwise, so it is positive. Here angle is moving clockwise, so it is negative. So that is the reason positive and negative is given. What is the relationship between the sexagesimal system and centesimal system means? Sexagesimal system, centesimal system, radius means, see, degrees, 1 degree is equal to 90 and 2c by pi, radians. Radians is nothing but 2c by pi. See, 2c by pi means pi is equal to how many degrees? Pi is equal to 180 degrees we can take normally. Normally, pi is equal to 180. Pi is equal to 180 degrees we take. 180 degrees. Okay, so here 1 degree is equal to pi by 180. Just before I discussed 1 degree is equal to, see, because pi c is equal to 180 degrees. Pi c is equal means pi radians is equal to 180 degrees. I want 1 degree means this 180 comes to denominator. Pi c by 180, pi c by 180 equal to 1 degree. 1 degree is equal to pi c by 180. See here. Here that is only given. 1 degree is equal to pi by 180 radians. 1 radian I want means this pi comes to denominator. It is 180 by 5 degrees. Right? Next. Observe this. See, pi is nothing but 180 degrees I said, no? So pi by 4 means 180 by 4 is 45 degrees only, no? 2 pi by 3 means 2 into 180 means 360 by 3. 360 by 3 is 120 degrees only, no? 7 into pi means 7 into 180 by 6. If you divide, you will get 210 degrees. Here is also same. Pi radians means pi means 180. 180 by 3 is 60. 3 pi by 4 means 3 into 180 by 4 means if you divide, you will get 135. Again 5 pi means 5 into 180 by 4. If you divide, you will get 225. Understand? Here very important angles. see the angles whose different, the angles whose different, the angles, the angles whose differ either 360 degrees, multiple of 360 degrees means we call it as a co-terminal angle. See here 420 degrees is there. 420 degrees is nothing but co-terminal angles. 780 degrees is also co-terminal angles because it is a more than 360 degrees are there. No, when the degree is more than 360 degrees is there means we call it as a co-terminal angles because we must add 360 degrees to that. See 420 degrees, how do we get to the 360? If you add 60 degrees you will get a 420. So 360 we are taking here means it is nothing but co-terminal angle. 780 degrees, how do we define? 2 into 360 plus 60. So again 360 we are using, no? So it is 780 degrees is called co-terminal angles. Understand? So what is the co-terminal angle formula? N times of 360 degrees plus theta. It is the formation of 360 degrees plus theta or n times of 360 degrees plus theta. N is nothing but 1 means 360 plus theta only, no? So 360 plus means more than 360 degrees if any angle formed, that angles can be called as co-terminal angles. Okay. Next, relationship. See, L is equal to r theta, very important. See, length of the arc, this is the length, arc length this is. So L is equal to formula r theta, very important. L is equal to r theta, where r is nothing but radius, theta is nothing but angle. You want r means, radius I want means L by theta it will become. You want theta value means theta is equal to L by r it will become. Understand? So this is the formations. Next, you know this already we discussed. And coming to trigonometry, just discussed means just angles formation, initial side, common side, this angles formation only there. Horizontal axis, horizontal line is called x-axis, vertical line is called y-axis. This is only information here. And coming to here, you know very well trigonometry. This is, see, we have types of triangles very well, you know. So this is a right angle triangle and this is hypotenuse. Hypotenuse will never change because the longest length in a right angle triangle is called hypotenuse, but opposite depends upon it. Suppose if theta is here, this will become opposite, you know very well. And this is A and this is B and this is C, right? A, B, C. If theta is here, this will become opposite and this will become adjacent, right? So suppose same one right angle triangle if I take one right angle triangle, okay. If theta if I take here, if I take the theta value here, this will become the opposite, this will become the opposite and this will become the adjacent. Okay, other side will become the adjacent and this is hypotenuse. Hypotenuse will never be changed, you know that thing. Okay, and one of the angle must be 90 degrees. And you know this sin theta, sin is nothing but a smallest side and starting side, right? So sin theta is nothing but first opposite is the smallest one, next hypotenuse is the largest one. So sin means opposite by hypotenuse, okay. And cos is nothing but next smallest side is nothing but what? Adjacent. So adjacent by hypotenuse, next see, just tan means tan is nothing but a tan theta can be write as tan theta can be write as sin theta by cos theta. What is tan theta? We can write sin theta by, it is not coming, okay, sin theta by cos theta. So just observe this. So hypotenuse is common in both, hypotenuse is common in this sin and cos. So P by H means opposite by adjacent is a tan. And just now I said sin, cos, tan are the three trigonometric signs. Their reciprocals are cosec, sec and cot I said. So cotangent is a reciprocal of tan. So it is reciprocal of tan means adjacent by opposite is a cotangent. Adjacent by opposite is a cotangent. And what about the secant? Sec and cos are reciprocals, I said. Means whatever the cos will be there, its reciprocal will become the secant. So what is the cos? Adjacent by hypotenuse. Then secant will become hypotenuse by adjacent. Observed. Next, sine and cosec are reciprocals, I said. What is sine? Sine is nothing but opposite by hypotenuse. Then what about the cosec? Hypotenuse by opposite. See, they are reciprocals. Reciprocals means if a by b means, if sine says a by b, cosec will say b by a. If tan says x by y, cot will say y by x. If cos says 3 by 4, 3 by 5, then sec will say 5 by 3. It is reciprocal. Okay, because sine, cos, tan are only the three trigonometric signs. Their reciprocals are cosec, sec and cot. Sine is a reciprocal of cosec, cos is a reciprocal of sec, and tan is a reciprocal of cot. Right? Next, here observe just description he has given. Observe this, very important. See, sine angles, types of angles. See, sine 0 is 0, sine 1 by 2 is, sine 30 is 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 90 1, sine 180 becomes 0, sine 270 becomes minus 1. See, here these angles are what, just up to 180 degrees. These are just, we have some other discussions we have as a teachers, you know very well, and how to explain this also. See, sine and cos are the reverse. Up to 90 degrees they are reverse, or up to this, all up to 90 degrees they are reverse. Sine and cos are reverse, and tan and cot are reverse up to 90 degrees. Cosec and sec are reverse up to 90 degrees. Okay, these things only define these things, what, 180 degrees and 270 degrees. You know that angles property, using angles property we can define this one, right? Next, and just before I said sine and cosec are reciprocals to each other. Product of the reciprocals is always 1, because see, sine will become 1 by cosec, cosec will become 1 by sine. Cos and sec are reciprocals, again their product will become 1. Cos will become 1 by sec, sec will become 1 by cos. And tan and cot are reciprocals, so their product will become 1. Okay, cot I want means if we can write 1 by tan, tan I want means we can write 1 by cot. Okay, these fourth one are nothing but trigonometric identities. What is the first trigonometric identity? Sin square theta plus cos square theta equal to 1. So cos square theta I want means this sin square theta comes to the left hand side, right hand side. It will become 1 minus sin square theta. If we remove this square, we will get root. Otherwise, sin I want means now cos will comes to the right hand side. So sin square theta equal to 1 minus cos square theta we can write. Same, what is the second identity? Secant square theta minus tan square theta equal to 1 is an second identity. I want secant square theta value means tan square theta I am taking to the RHS side. It will become 1 plus tan square theta. I want what is tan value I want means tan I am taking right hand side, 1 I am taking this left hand side. It will become tan square theta equal to secant square theta minus 1. And what is the third trigonometric identity? Cosecant square theta minus cot square theta equal to 1. I want cosecant square theta means this cot will go to the right hand side, move to the right hand side. It will become cosecant square theta is equal to 1 plus cot square theta. I want cot square theta means this plus cot square theta move to the RHS, 1 move to the LHS. So cot square theta will become what? Cosecant square theta minus 1. Now, as you know very well, just before I discussed, tan theta means sin by cos, cot theta is nothing but reciprocal of tan, no? So cos by sin. So this is the completion, and thank you very much. If further any doubts, clarification you want, you can contact us. You have, every school have our numbers. You can contact us and you can speak without any frankly you can speak whatever the doubts you have. We are ready to clarify and we are ready to discuss with you. Thank you, teachers.
ಸರಿ 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 ಹಾಂ ಸರಿ ಹೌದು